All right, so here we're taking a look at Hess's Law short. This one is a lot quicker than Hess's Law long. This is also known as Hess's Law mathematical. When you do this type of equation, you do need to use your data booklet. If you're following along with the Alberta curriculum, you need page 4 or 5 to get those standard enthalpies of formation. And then we can start the process. So here you're still figuring out the enthalpy change. So we want to figure out the delta H of this reaction. And to do that, we're going to look up those enthalpies of formation. So the enthalpy of formation of carbon dioxide is negative 393.5 kilojoules per mole. But we're going to take that value and multiply it by how many moles we have. So we have 6 moles, so we'll take that. Then we'll look up the same for water. So we'll take the 6 moles of water and multiply it by negative 285.8 kilojoules per mole. With water, you do want to pay attention to the state. If it was the gas state, it would be a different value. Then on the product side, glucose is negative 1,273.3 kilojoules per mole. And oxygen, because it's written by itself, that would be 0 because it doesn't need to form, so it would not have an enthalpy of formation. Sorry there, I just went back or too forward there. So it would be just 0. So that's all we would write in here. So of course, anything times 0 is just 0. Then you want to get the sum of each side. So the reactant side, if you did 6 moles times the negative 393.5 kilojoules per mole, your moles cancel and we would have negative 2,361 kilojoules. We need to add that to 6 moles of the water times the enthalpy of formation of the water, and that would give us negative 1,714.8 kilojoules. And on the right hand side, the product side, we just will write down the enthalpy of glucose once again. And if we did multiply it by 1 mole, your moles would cancel and we just have kilojoules. Now let's add the reactants together. The reactants together is negative 4,075.8 kilojoules. And again, your product side, we'll just write down that value again. Now that we know both, when we want the delta H of the whole reaction, you would take the sum of the products minus the sum of the reactants. So just in a really easy formula, I just write down P minus R, but we are taking the sum. So then we'd have negative 1,273.3 kilojoules minus negative 4,075.8 kilojoules. And we would do the math and we would see our value is positive 2,802.5 kilojoules. So that would be the enthalpy of the reaction for photosynthesis. And hopefully that would make sense because that number that we're getting out is endothermic. And we know that photosynthesis harnesses that sun energy and it should be an endothermic reaction. Thank you for watching. Bye.